Thank you for your interest in Quadra Fire. We believe the Quadra Fire 1000 and 1100i pellet burning appliances are the finest pellet burning stoves on the market today. But like all fine machines, they need service periodically to remain in prime condition. And that's where you come in. Quality service is important to our customers. In the next few minutes, we'll give you an introduction to the unique ignition system, and we'll cover a few of the safety-related features of the Quadra Fire 1000. We will then give a few installation tips, cover adjusting procedures, and other dealer service issues. We hope this information helps you do your job better. Thank you for your attention. To begin, we will explain how the Quadra Fire 1000 works. The 1000 is an advanced appliance with a revolutionary self-ignition system that provides ignition within minutes of startup. The fire in the stove is then controlled by a number of automatic sensors and safety systems. Together, they make stove operation simple, easy, and safe. The Quadra Fire 1000's automatic ignition sequence is very sophisticated and highly dependable. In fact, the cycle is so advanced, it's simple. Basically, when the stove gets a call for heat, timers run the stove until it gets to a certain temperature. Then the stove stays running by temperature and thermostat demand. The stove returns to timers for its shutdown when the room thermostat is satisfied. Operating a Quadra Fire unit is as easy as adjusting your thermostat. When a thermostat connected to the system is turned up, it sends a call for heat, and the stove starts on an automatic ignition cycle. On the appliance, the call light comes on, indicating the stove is receiving a call for heat. The combustion blowers come on, creating a partial vacuum in the burn pot, and the feed system starts, delivering a few pellets to the fire pot. At the bottom of the burn pot, the igniter comes on. Ignition is sensed and monitored by a thermocouple in the fire pot. A low flame will send a temperature reading of 200 degrees to the control box. If this happens within 2 minutes, the igniter will turn off and the feed motor will continue to operate, allowing the fire to build. If 200 degrees is not sensed in about 2 minutes, the feed motor will stop, but the igniter will stay on for about 4 more minutes. This allows fuels that are more difficult to light a bit more time to start burning. When ignition occurs, it will heat the thermocouple to 200 degrees, signaling the control box. The green light on the control box will light and the feed motor will resume delivering pellets. The stove is now in transition from startup to normal operating temperatures. The incoming fuel means the fire will increase in size, sending a hotter 1000-degree message to the control box. At the control box, the red light comes on, signaling that the stove is operating normally. Once this happens, the stove will continue to burn until the thermostat is satisfied. Essentially, the stove has only one setting, full on. This provides the most efficient combustion possible. The bottom line is, we put more heat per pound of fuel into the room. The shutdown sequence is also timed. When the thermostat is satisfied, the call light goes out and the stove goes from its burn cycle to a shutdown cycle. The feed system turns off, stopping the flow of pellets to the fire pot. The combustion blowers continue to run for about 8 minutes, burning and exhausting the remaining fuel in the fire pot. As you can see, the open flame here has gone out, and burning embers are blowing out of the fire pot. This is how the fire pot cleans itself. Then the combustion blowers shut off until the thermostat again calls for heat. The convection blower moves air over the heat exchanger, delivering heat into the room. It's totally automatic and totally temperature controlled. It turns on when a temperature of 145 degrees is sensed in the convection chamber. This blower will continue to remove heat even after the fire is out. When the temperature in the convection chamber falls below 105, it will turn off. This automatic startup and shutdown sequence makes the appliance both easy to operate and very dependable. There are also 3 safety devices built into the stove. First, there is a vacuum switch that will turn off the feed motor if the front door is opened or if the exhaust system becomes clogged. Second, there's a snap disc that will turn off the stove like a thermostat does. This can happen if the convection blower doesn't turn on or if it fails while the stove is running. Third, Another snap disc turns off the stove if the pellets at the top of the feed tube reach over 200 degrees. The pellets ignite at about 400 degrees, so as you can see, we have a wide margin for safety. Next, let's look at what the individual components do and locate them within the unit. Please note how the components work together in automatic systems. A thorough understanding of how the systems work will greatly aid troubleshooting. For our guide, we've asked Holly from the Aladdin Steel Pellet line to join us. We'll begin by opening the front access door and removing both left and right side panels, and both blower access doors.
To remove the left access door, use a flat-bladed screwdriver. Loosen these 4 screws to remove the side panels. The right side is the same as the left side.
We're just doing this so you can see better. The components are easy to reach inside. In most cases, you will not have to remove all of these at once. We'll begin with the power supply. On the 1000, it's by the right rear. A standard current of 120 volts, 60 hertz is required to operate this stove. For safety, the unit should only be attached to a properly grounded receptacle. For an alternative power supply, you may use a generator that produces a minimum of 700 watts AC power. Right where the power cord comes into the back of the unit, we have the fuse. The fuse is a standard 7 amp AGC7 120 volt fuse. To check it, push in on it, turn it counterclockwise, then pull it out. The stove is designed to run on a 24 volt AC thermostat. The thermostat turns the stove on by closing the thermostat circuit when heat is required. This is the most economical kind of thermostat to purchase, but it is also not as consumer friendly. It has a set of points that seem to keep the thermostat engaged to a setting generally higher than the set temperature. Likewise, it won't trigger until it is well below set temperature. This means a wide temperature swing in the consumer's home. The second style has a glass bulb with mercury inside of it. The mercury style won't have such a wide temperature swing, yet it's still very reasonably priced. It's important to mount this style of thermostat level. If it is not, it will give a false reading. The light is on the right side of the junction box. The light is a 28 volt AC bulb, number 85 lamp. It indicates that the thermostat is calling for heat. The restart button is just beside the light. When pushed, it momentarily opens the thermostat circuit. When released, it closes the circuit, restarting the automatic ignition cycle. Note that the restart button will only work when the thermostat is calling for heat and the call light is on. Many of the automatic systems on the Quadra Fire 1000 are triggered by snap discs that sense the temperature in various parts of the unit.
Now let's look at where the 3 snap discs are located.
This is the first snap disc to the right. This snap disc turns the convection blower on and off as needed. This disc senses the temperature in the convection air chamber. It turns the blower on when it reaches 145 degrees Fahrenheit and off when it falls to 105 degrees. This is the second snap disc from the right. It has 2 yellow leads running from it. It's an important safety system. It senses the temperature in the convection air chamber and turns the stove off if an overfire occurs or if the convection blower fails. This disc opens at 250 degrees and breaks the thermostat circuit. It automatically resets when the stove cools down. This disc is mounted on the feed tube and has 3 black wires connected to it. It is another safety device. It will not allow pellets at the top of the feed tube to exceed 200 degrees. So if the fire tries to burn back into the feed system or exhaust pushes up the feed tube, this disc will turn the stove off, just as if you've unplugged it.
Now let's take a look at the blowers. We'll start with the combustion blower.
This blower is located on the left side of the pedestal towards the rear of the stove and is accessible through the small door on the left side of the pedestal. This blower delivers all the combustion air that passes through the fire pot and helps control the height and velocity of the fire. It regulates the pressure in the chamber located underneath the fire pot. The exhaust blower is accessed from the right side. This blower pulls exhaust out of the firebox through the fins of the heat exchangers. This creates a slightly negative pressure or partial vacuum in the firebox. It works in conjunction with the combustion blower to create a proper burn. The pressure below the fire pot will be slightly positive. Above the pot in the main chamber, the pressure will be slightly negative. But from this point out, the exhaust system is under pressure and any connections in the exhaust system need to be well sealed. The convection blower is accessed from the left. This blower circulates air over the heat exchangers and delivers heat into the room. Remember, this blower is controlled by snap disc number 1. It functions automatically as long as there is heat in the stove. Back here on the wall is the vacuum switch. This is a safety device designed to shut off the feed system if the front door is open, the exhaust blower fails, or the exhaust becomes plugged by ash or any other foreign material. The switch must sense vacuum from the firebox chamber in order for the feed motor to run. There's a small hose from the vacuum switch to the feed tube that lets the switch sense the vacuum in the firebox. This system pulls pellets up the feed tube from the hopper and drops them down the feed chute into the fire pot. The feed system on the Quadra Fire 1000 is unlike any other feed system in use. It has a coil spring without a solid center shaft. The spring is much smaller than the diameter of the tube it fits into, eliminating tight clearances. This means that it won't cut or grind pellets into sawdust. It is highly resistant to jams and is one of the special features that makes our product so superior to other pellet burning appliances. The feed system delivers pellets to the fire pot. The fire pot is made of cast ceramic and is designed with air intake ports or holes that swirl the fire and help to remove ash. In fact, when there is a fire in the fire pot, air entering from the bottom creates a cyclone of fire. It's important that these air holes are not plugged or blocked in any way. To make cleaning the fire pot easier, a removable clean-out plug was designed into the bottom of the fire pot. The igniter is located in a bottom chamber of the fire pot. The element is suspended above the lower end of the ramp on the clean-out plug. The igniter is made of a cast silicon carbide ceramic material. The element quickly reaches a temperature of 2600 degrees Fahrenheit when power is applied. When the stove is starting up, a few pellets will fall down the ramp. The igniter superheats the air, which swirls around them and ignites them. This flame then flows up the ramp into the main burn chamber of the fire pot, where it ignites the rest of the pellets. Once the fire is burning, airflow up the ramp stops pellets from coming down the ramp. The thermocouple is protected by a ceramic tube called the thermocouple protection cover. The thermocouple itself is two wires made of different metals that, when joined together, produce a small amount of electricity, which increases with the temperature. The thermocouple senses the temperature of the fire, and when it reaches 200 degrees, it will turn on the green light on the control box. Then at 1,000 degrees, it will turn on the red light. The control box houses the electronics which control all functions of the stove except for the convection blower, which is controlled by snap disk number 1. In essence, this is the electrical brain for the stove. The solid-state logic in the control box means that if the thermostat is calling for heat, the stove will automatically relight after a power failure. The control box plugs into the junction box. The junction box houses the wiring harness, the power cord, the fuse, the restart button, and the thermostat call light. Quadra Fire has the most efficient heat exchangers used in the pellet stove industry today. The heat exchangers have been made with aluminum because it has 10 times the thermal conductivity of stainless steel. Heat exchange efficiency is determined by surface area, so finned heat exchangers were used. The fins dramatically increase the surface area for heat exchange within a relatively small space. There are 2 aluminum finned heat exchangers on this stove, one large and one small. The large heat exchanger is located at the top of the firebox. The other is at the back of the unit, just above the exhaust blower. We will demonstrate this installation using a cutaway wall so we can show you both sides. With the hole in the wall already cut, install the through-the-wall kit. Now, silicone the 3-inch outlet on the stove and slide the pipe onto it. Thoroughly silicone the joint. Make sure you get a good seal because the exhaust will be under pressure. If you do not, it will leak. Next, while guiding the pipe through the wall, slide the stove into position. The stove is safety listed for installation as close as 2 inches to combustibles. The stove exhaust is approved for termination 12 inches outside the house, but for a proper installation, we strongly recommend going vertical for at least 8 feet or above the eaves of the house. This will allow the stove to have some natural draw in the event of a power failure or a blower failure in the stove. We recommend using a T when starting to go vertical to help simplify the cleaning of the exhaust system. You should also seal all joints even though they are outside the house. An unsealed joint will leak exhaust and will create a dark spot outside the house. After installing the vertical pipe, an elbow will work to turn the exhaust away from the house. Be sure you secure the pipe to the house adequately. If the exhaust system is somewhat creative, meaning numerous elbows and 45s, we suggest that you step up to a 4-inch exhaust. If the exhaust run is going to be 20 feet or more, you should also step up to a 4-inch pipe. The larger diameter pipe will help eliminate back pressure created by extra elbows or length in the system. When replacing an existing wood stove, or if there's a good chimney in place, we recommend using the 3-inch to 6-inch top vent kit. Begin by putting high-temperature RTV silicone around the exhaust pipe out the back of the stove. Then place the top vent onto the exhaust pipe. With the kit straight, slide the outer shroud until the top surface of the shroud is even with the stove top. Now tighten the adjustment screws on the shroud. This will hold it in place for the rest of the mounting procedure.
After tightening the remaining 5 screws, square the collar with the top of the stove.
Now, using the bit provided, drill a hole in the top corner. Then recheck the level. Drill the remaining 5 holes and finish attaching the top vent kit.
A simple tip: insert the gasket sideways, just start the screw, drill the holes for the other 5 screws, insert the gaskets the same manner, turn them all flush, and then tighten the screws.
You must maintain a 3-inch clearance to combustibles from the back of the pipe. You can use 6-inch single wall pipe and duct into any Class A chimney or masonry flue. In a manufactured home, use only approved pipe. The exhaust will be under slight pressure from the exhaust blower, so we recommend using silicone on all the joints. To install a floor or wall outside air kit, remove the 4 screws from the screen on the back of the pedestal and remove the screen.
Outside combustion air comes from the floor or the back. Either kit will require installation of this gasket.
Install the rope gasket between the pedestal and the hearth pad. Note that this is not necessary on the Gold 1000 model. Install the rear vent or the floor vent plate by gluing them into place with silicone. Be sure the 2 small tabs are secured in the tab holes located in the pedestal riser. Now, run a bead of silicone around the edge of the plate. Reinstall the rear screen with the floor kit or the new screen with the wall kit. Once the stove has been installed, you are ready to burn the unit for the first time. You will notice when you plug the stove in that the blowers come on. Make sure the thermostat is set below room temperature. Next, take a handful of pellets and put them into the fire pot. This will let the fire start even though the feed system is not full of fuel. Close and latch the door. Now adjust the thermostat to a setting above the current room temperature. The stove may not stay burning on the first try, so it may be necessary to add more fuel by hand or push the restart button. Let the stove run for 15 minutes to reach operating temperature before attempting any adjustments. Remember, there are 2 things that are necessary to keep the stove running. 1, the thermocouple must read 1000 degrees Fahrenheit, and the thermostat must be calling for more heat. If either of these conditions is absent, the stove will go into shutdown mode. A properly adjusted fire has a short, active flame pattern. This fire has tall flames with black tails, and you can see it's somewhat lazy. Start adjusting this type of fire by sliding the feed adjustment plate down about 1/2 inch. Within about 5 minutes, your adjustments will have taken effect. If the fire is still too tall, lower the feed adjustment plate again. If the fire is still lazy and you've reached the end of travel for the plate, inspect the fire pot gasket. If the gasket is properly seated, you will need to open the air adjustment on the 30 CFM combustion blower. Open it in about 1/4 inch increments until the fire has a nice active flame pattern. Note, before adjusting the air on a stove that's been installed for a time, check the exhaust system for any obstructions. This fire is properly adjusted and has short active flames from 2 to 4 inches out of the fire pot. When the fire is too small and rarely peaks above the top of the fire pot, like this one, then you will need to increase the feed rate by adjusting the plate upwards. If the plate reaches the end of travel and the fire is still low and very active, you will have to close the air adjustment on the 30 CFM blower until the flame is properly adjusted, like this one. Take some time with the new installation and instruct the customer how to do this procedure. Show them how to adjust the feed rate. Explain that if the glass is getting black, the fire is probably too high, and that the fire pot will have to be cleaned more often, and that the heat exchangers and exhaust system will also need more frequent cleaning. It may be necessary to adjust the feed rate if they change brands of fuel. Fuel pellets are basically made from sawdust or wood byproducts. If the source material was hardwood, it will have a higher mineral content, creating a heavier ash. Minerals and other unburnable materials such as sand will turn into glass when heated to the extreme temperatures our fire pot reaches. This is what forms clinkers in the bottom of a fire pot. Trees from different areas will vary in mineral content. That's why some fuels make more clinkers than others. Pellets are manufactured in either 1/4 inch or 5/16 inch diameters and many varying lengths. Pellet length may even vary by lot from the same manufacturer. This is why the feed rate may need to be adjusted occasionally. We recommend that consumers buy fuel in multi-ton lots whenever possible. Buying larger quantities of fuel at once will greatly reduce the number of times the feed adjustments will need to be made. In order to troubleshoot the stove, you must first determine what shut the stove off. We'll assume that the thermostat is calling for heat and the red call light is on the right side of the stove. If this is the case, you will now have to look in the fire pot to see what state it's in. It will be one of 3 possible scenarios. The first possibility is that there are unburned pellets in the fire pot. This tells us that the stove has simply missed an ignition. Clean the fire pot and pay attention to the amount of ash and clinker buildup in the stove. If there is very little ash, it may be possible that too much air is passing over the igniter. If this is the case, the stove will have always had slow starts. In rare cases on some of the early S7 fire pots, which is the gray, heavier material, the air hole over the igniter may be too large. You will need to restrict the airflow over the igniter. This can be done using stove gasket cement and restricting this hole by about half. When done, it should be no smaller than 1/8 of an inch tall by 3/4 of an inch wide. Be sure to allow at least 1 hour for the cement to set properly before lighting a test fire. If there was a lot of ash, find out how long it's been since the stove was cleaned. If it was just cleaned, we either have poor fuel or the stove is burning with a lazy fire. A lazy fire can result from a bad fire pot gasket, too high a feed rate, or a plugged exhaust. Be sure the exhaust system is clean and check the heat exchangers to see that they're not plugged. Now, start the stove and read the fire. It may be necessary to reduce the feed rate and/or increase the air at the 30 CFM blower. It's important that you end up with a nice active flame pattern that reaches 2 to 4 inches out of the fire pot. The second possibility is that there are partially burned pellets in the bottom. As you can see, the pellets on the right side of the pot are gone, but on the left side the pellets are scorched. This tells us that the fire started, but it never reached 200 degrees. This points to the thermocouple. It either was not in the pot or the protection tube was not touching the end of the thermocouple. If it appears to be properly installed, you will want to remove the protection tube and inspect the welded end. If the end has eroded away or the wires have broken, like this one did, you will need to replace it. The third possibility is that the fire pot has some ash and is free from pellets, just as if the stove went through a normal shutdown. First, look for fuel in the hopper. Remember, Our feed system is unique in that as the fuel gets to the bottom of the hopper, it will reduce the feed rate and the fire may drop to below 1,000 degrees, shutting down the stove. It could be as simple as the end of the protection tube is not in contact with the thermocouple, or the thermocouple is not properly located in the fire pot as seen here. If that does not appear to be the case, it is probably related to the vacuum switch. As you know, low vacuum in the firebox can cause the vacuum switch to turn off the power to the feed motor. That in turn will let the fire pot temperature drop below 1,000 degrees, which in turn will shut the stove off. A couple of things can cause low vacuum. The exhaust system can be dirty, which includes the heat exchangers, the pipe from the stove out, and the cap on the exhaust pipe. The cap may have a screen in it, which could be plugged. Also, the larger the fire, the lower the vacuum. So if the feed rate is too high and the fire gets big and lazy, the vacuum can drop so low that the vacuum switch will turn off the power to the feed motor. As the fire dies down, the vacuum will increase and the feed motor will turn back on. This cycle can continue until the fire pot drops below 1,000 degrees. It's very important that the fire be adjusted to a fairly short, active flame pattern. There are two aluminum-finned heat exchangers on the stove. One, known as the large heat exchanger, is located at the top of the firebox and is accessible through the front door. To clean the heat exchanger, remove the cover by sliding it upwards towards the door. It should then fall into your hands. Clean the heat exchanger and vacuum out the ashes. Remove the cover plate just inside the main door, then lift out the ash pans and empty them into a metal container, making sure no hot embers remain. Clean inside the cabinet as needed. Remove the small cover plate located against the back of the firebox. To do this, place a screwdriver or similar tool into the feed tube and lift upwards. The cover should then pull forwards towards you. Brush and then vacuum the heat exchanger and heat exchanger housing. When cleaning the small exchanger, connect the vacuum cleaner to the cleanout at the bottom of the T, or any other cleanout close to the stove. Now, with the thermostat set below room temperature, plug the stove in. The combustion blower will come on. This will help remove ash from the bottom of the chamber under the small heat exchanger. There is a ring-shaped gasket between the firepot and the firebox floor. If it should be necessary to remove the firepot, be sure to inspect this gasket and replace it if needed. We have used several types of castable ceramic firepots in the Quadra Fire 1000. As the firepot wears, the hole going down to the ignition chamber will enlarge slightly. Also, the dome will show a reduction in size and some wear. This is normal and will not affect the function of the firepot. If there's no breach in the firepot's surface, the pot is good. With wear, a hole may form in the firepot wall by the ignition chamber. Note how this hole looks from outside of the firepot. Or the dome may develop a hole in it as we're using this flashlight to show you. The pot will need to be changed. To clean the firepot, be sure to unplug the stove first. Open the front pedestal access door and remove the plug from the base of the firepot. Now, open the main door and use the scraper to clean the fire pot. Scrape the bottom of the pot and the ash will fall into the pan below. Remove any debris on the cleanout plug and reinstall it in the bottom of the fire pot. When you are finished, dump the ashes into a metal container. No cleaning of the igniter will be necessary. The igniter may be visually inspected by removing the cleanout plug from the fire pot. The element is very brittle, so care must be taken in handling it. It is important that the doors seal tightly. With wear, the handle may become loose. To tighten it, remove the nut, the cam, and the keeper. And lastly, a washer. Discard the washer and reassemble the handle. The door should now fit snugly. Try not to over-tighten the handle when reinstalling. The intake blower should be checked for dust accumulation and cleaned every 6 months. This blower requires no lubrication. When cleaning, you will need to remove the set screw on the air adjustment plate. If the screw is already removed, be sure to mark the position of the plate. Open the plate wide and you can now access the impeller fins with a small nozzle and brush from your vacuum cleaner. Also, clean out the whole compartment to help reduce dust getting into the stove. Be sure to put the plate back into position when you are done. When you are cleaning the small heat exchanger, the impeller on the exhaust blower can be visually inspected with the aid of a flashlight. To clean it, vacuum around the housing and the motor. There are 2 oil ports on the top of the blower. Never put more than 1 or 2 drops of oil in either port. Any more oil will run out of the bushings into the windings, causing permanent blower failure. The convection blower should be cleaned at least once each heating season, or more often if there are pets in the house. The impeller on this blower can be cleaned with a brush and vacuum. However, it's difficult to get all the dust, and some of it will fall into the blower housing. Take special care to vacuum as much as possible to avoid getting it into the house. We will now revisit the elements in the stove, giving directions for part testing and replacement. Be aware that there is a shock hazard whenever you work on the unit while power is supplied to it. The light is a 28-volt AC bulb 85 lamp. If replacement is necessary, remove the lens cap by turning counterclockwise about a 1/16 of a turn. The cap will then pull straight off. To remove the bulb, pull it straight out without turning it. The stove is designed to run on a 24-volt AC thermostat. We recommend that you use a new thermostat when installing this stove. Almost all thermostats have a heat anticipator, which is simply a miniature heating element built in. The heat anticipator must be adjusted to match the current rating draw of the thermostat circuit. On the Quadra Fire 1000 or 1100i, the current rating is 0.05 amps. That's a lower setting than most heat anticipators will go to. So the heat anticipator should be set to the lowest setting possible. This will give your customers the best performance. The disc will have the numbers F145-40 on the side. Should this disc fail, the convection blower will either run continually or fail to turn on. If either problem occurs, the disc will need to be replaced.
Here's a tip. Remove the top wire first, then the 2 screws. Then you can use the bottom wire as a handle to remove the snap disc.
The order of the wires does not matter when reconnecting the wires. This is the second snap disc from the right and has 2 yellow leads running from it. It will have the numbers L250-40 on the side. This disc opens at 250 degrees Fahrenheit and breaks the thermostat circuit. It will automatically reset when the stove cools down. If the thermostat will not turn the stove on, a quick test of this disc is to temporarily bypass the disc by shorting the leads. If the stove now comes on, replace the disc. It will have the numbers L200-M on the side. This disc rarely requires replacement. All of the power for the stove flows through it, so if any part of the stove turns on, the disc is working. Sometimes in shipment, the disc will trip, shutting off power to the stove.
I will remove the top wire so you can see the reset button.
To reset the disc, unplug the stove, push the red button, and then when you plug the stove back in, the combustion blower should start. If replacement is needed, disconnect the 3 black leads and remove the mounting screw. When reconnecting the new disc, the order of the wires does not matter. Should this blower fail, the stove will continue to operate. However, the fire will not burn properly and the fire pot will quickly fill with ash and clinkers. To replace the blower, remove the access doors on the left side of the stove and disconnect the 2 motor leads. Now, open the front pedestal access door and remove the 4 nuts from the blower studs. The motor will now come free. Inspect the gasket and reinstall the new blower. New blowers each have slightly different outputs, so be sure the fire is properly set before you leave. Should this blower fail, a positive pressure will build in the firebox. This will trip the vacuum switch and shut down the feed assembly. This blower is thermally protected, and in rare cases on some older models it may experience nuisance shutdowns with a prolonged burn. It will automatically reset when the motor cools. A good test for this condition is to temporarily remove the right access door, allowing the motor to run cooler. If this cures the shutdown problem, then replace the access door with a vented one. A tip: use a flexible drive to access the nuts on this blower. To replace the blower, disconnect the motor leads and remove the 2 nuts holding the metal strap clamping the blower outlet to the exhaust pipe. Because it's siliconed on, you'll need to pry the strap off with a screwdriver. Now you can remove the 4 nuts from the housing bracket. And because the blower is also siliconed on, you'll need to pry it off with a screwdriver. When you reinstall, remember to apply high-temperature silicone to the blower, to the gasket, and particularly around the clamping strap in order to seal off the exhaust. The system will be under pressure, so take extra time here to ensure that you get a good seal.
Make sure you put silicone on both sides of the hole.
If this blower fails, the temperature in the convection chamber will increase, triggering snap disc number 2. To replace this blower, remove the left side curtain and disconnect the motor leads. Now push the insulation away. The wire retainer is held by the top left screw. Remove the 2 bottom Phillips screws, then the remaining top one. The blower will now pull free. We have used 3 different styles of vacuum switches on the Model 1000. The first style was mounted inside the junction box. This switch is adjustable, and if out of adjustment, you may hear a chattering or clicking sound coming from the control box. If so, the switch will either need adjustment or replacement. To adjust it, remove the vacuum hose, then the yellow tape on the lower left corner of the switch, and locate the adjustment screw. Turn the thermostat up above room temperature and verify that the red call light is on before proceeding. Now push the restart button. Gently turn the adjustment screw clockwise until the feed motor starts. Then back it off about 2 degrees until the motor just stops. When you reconnect the vacuum hose to the junction box, the motor should restart. Test the adjustment by letting the stove run for about 15 minutes. When you open the front door, the motor should stop within 5 seconds. When you close the front door, the feed motor should start within about 20 seconds. If it does not, readjust the vacuum switch. If the switch causes consistent problems, we recommend upgrading the switch. To install the new style vacuum switch, first disconnect the vacuum hose. Locate the adjustment screw and turn it all the way in the clockwise direction. Now, with the new vacuum switch, remove the double back tape and mount the switch just above the junction box, like this. Replace the vacuum hose with this longer one. Now, disconnect the red wire that goes to the feed motor. With this longer set of jumpers from the kit, connect one end to the red wire and the other to the wire going to the feed motor. Now connect the other ends to the vacuum switch. Now restart the stove and make sure everything is operating properly. The second style vacuum switch used was mounted on top of the junction box. It also was adjustable, but to adjust it, it had to be removed from the top of the junction box. Loosen the 3 mounting screws. They do not need to come all the way out of the switch. Tip the switch up and locate the Allen screw in the bottom of the switch. The switch will need to be sitting level on the top of the junction box when testing. After adjusting, be sure not to tighten the mounting screws too tight, as they can bind the vacuum switch. When reconnecting this vacuum switch, one lead should go to the vertical terminal. The other should go to the terminal marked on. If upgrading this switch to the new style, remove the vacuum hose and the vacuum switch. Disconnect the 2 red wires from the switch. Now install the new switch directly above the junction box, just like before. Use the short set of jumper wires and connect them to the 2 red wires coming from the junction box and to the new vacuum switch. Now install the new vacuum hose and retest the stove. Our current vacuum switch is mounted with 2 screws, and if replacing it, You must disconnect the 2 red wires and the vacuum hose. Remove the 2 screws and replace the switch. Here's a tip. If the feed motor fails to run and you suspect the vacuum switch, you can bypass the vacuum switch by removing the 2 red wires from the switch and using a short jumper. If the feed motor now runs, be sure to check that the vacuum hose is free from any obstruction. Sometimes the nipple mounted on the feed tube may get plugged. If the hose is clean and the vacuum is present, the switch may need to be replaced. Anytime work has been done on the vacuum switch, be sure you test it by letting the stove run until it is hot, about 15 minutes. Then, open the front door and see that the feed motor stops within about 15 seconds or less. Now close the front door and the feed motor should restart again within about 15 seconds. On this stove, the feed motor and the feed screw are all part of one assembly and will be removed as one unit. The feed motor runs on a 120-volt AC power supply. If the feed motor fails to start and power is present at the motor, it will be necessary to remove the assembly. To do this, first remove both side curtains. The stove top will also need to be removed. It is secured by 4 wing nuts, 1 on each side and 2 nuts inside the hopper, at either end of the hinge. Reach into the hopper and remove the wing nuts. Then reach in from the side and remove the front wing nuts. The top will now lift off. Now remove the red and white leads to the feed motor. Remove the 2 bearing mounting nuts and the entire feed assembly will pull free. When reinstalling the feed assembly, it's not necessary to remove the fuel from the hopper. Just push the feed assembly back into place as far as it will go. Reconnect the motor to the power supply, and it will auger itself back into position. Now reinstall the bearing mounting nuts. To change the fire pot, open the front pedestal access door and remove the cleanout plug and ash pan. Next, open the main door and remove the ash pans. Carefully move the protection tube and thermocouple away from the fire pot. Reach around the fire pot and remove the 2 ceramic wire nuts. Gently but firmly tip the fire pot forward and out the front door. To get enough clearance to do this, it may be necessary to first remove the top heat exchanger cover. When reinstalling a fire pot, carefully inspect the ring gasket. It's important that the fire pot make a good seal and that it be pushed firmly to the back. A flat stove glass mounting gasket may be substituted here if a proper ring gasket is unavailable. To replace an igniter, remove the fire pot as we just showed you. There are 2 things to remember here. First, the gasket around the igniter must be in good condition. To install a new igniter, slide it into place. Then pack the gasket firmly around the igniter with a small screwdriver. Be sure to center the element in its access hole. The other thing is that the igniter is fairly fragile. Any side pressure on it and you'll snap the element, so be careful.
A tip when installing the wire nuts. If you keep the multi-strand wire that goes to the junction box slightly higher than the wire coming from the igniter, it should go together very easy.
The type used in this stove is a K-type. The thermocouple is covered by a ceramic protection tube and should protrude approximately 1 inch into the fire pot from the right-hand side. The temperature is sensed at the end of the thermocouple. Therefore, the cover should always touch the end of the thermocouple. If a replacement is necessary, use only a K-type thermocouple. To replace it, pull the thermocouple through the firebox floor, then through the Hayco fitting in the back wall of the chamber. The yellow positive wire is connected to the junction box terminal in the center closest to the front of the stove. The red negative lead should be connected to the center back terminal of the junction box. To replace the control box, remove the right-hand side panel. Now you can access the mounting bracket. Remove the screws and the bracket, then unplug the control box from the junction box by pulling it straight out. To reinstall, simply reverse this process. The junction box is replaceable as an entire unit. Begin by disconnecting the thermostat wires. And remove the vacuum switch leads and the control box. Next, remove the vacuum hose and disconnect the thermocouple leads. Now, disconnect the igniter leads from the igniter by removing the white ceramic wire nuts behind the fire pot. Remove the leads to snap disc number 1. The yellow leads to snap disc number 2 are next, then the 3 black leads to disc number 3. Disconnect the red and white wires going to the feed motor. Next, remove the wire retainer mounted to the upper left bolt of the convection blower. Then remove the leads going to the blower motor. Next, disconnect the blue and white leads to the combustion blower. Now use a small screwdriver to pry the rubber grommet from its hole. When it is free, carefully pull the wires through the hole one at a time, taking care not to damage the terminals. Finally, from the right side, remove the screw below the light and restart button. Next, loosen the back mounting screw and cut the plastic wire retainer adjacent to it. Then carefully remove the junction box. To install the test box, remove the control box and replace it with the test box. The test box will give you control over each of the systems on the stove.
If you need to test the convection blower, plug this wire into the purple lead off snap disc 1.
Remember that the combustion blower must be on for the feed motor to run. The test box has its own 6-amp fuse. This is 1 amp below the stove's fuse, so that if there is an electrical problem in the stove, the test box will trip first. We know this material will be helpful in making your job easier. On behalf of Holly and the rest of the Aladdin crew, we'd like to thank you for your time viewing this tape.